Okay. All right, very well. So now this is recording. And what I would like to do today is I would like to go over the kinematics of rolling objects. All right. Let's say if you have a well, before I do that, I want to ask you a quick question regarding the angular velocity. So let's say you have this, rigid body, right? This guy will have an angular velocity omega, right? Meaning that, what do you think? So this rigid body will have an angular velocity. How about a point? Can a point have an angular velocity?
A point, no.
No.
A point cannot have an angular velocity, right? Exactly. So it's only lines that can have angular velocities. All right. So if this rigid body is rotating, then this line will be rotating the same angular velocity as this line, etc. I would like to give you guys a question. Is the merry-go-round, in the playground, right? Let's say you went and then you are sitting on this merry-go-round, and you're sitting here. Your friend jumped on this one here, and then he's sitting there. And one of your other friends will actually decide to really go far away, and he wanted to be somewhere over here, right, sitting on a chair over here. So there are some merry-go-rounds that actually look like that. And let's say you were sitting here, your friend, this is you at A, at B, and then one of your other friends was actually sitting there. Which one do you think is going to be spinning faster, A, B, or C?
The one who is closest to the point of rotation. يعني وين عم بيصير فيه الانجلر velocity اللي أقرب عليها بيكون he's rotating faster.
Yeah, which one guys do you think is going to be rotating faster? Like if you had this equipment, right, where would you want to sit? Like, you went to the playground, and then where would you want to sit, A, B, or C, so that you reduce how busy you get, for example?
C.
At C? Okay, well, you get dizzy by. Do you guys agree that you get dizzy by?
It's not when R is bigger, then the velocity would be bigger because they have the same omega.
Right, but here I'm referring to the angular velocity, not the actual velocity. So which person?
Is it the same?
Yeah,
which person?
Yeah, which person do you think is going to be spinning more, like A, B, or C? Like for every revolution of this, for this equipment, which one do you think is going to be rotating more around himself?
A.
A is going to be, so for every turn of this frame, basically, A will rotate let's say 2 times, right? And then B would rotate 1 time, and then C maybe will not rotate. Is that true?
No, they all rotate the same way.
I'm sorry?
Don't they all go in the same pattern? يعني ذات rotations?
Exactly. So for every rotation of the machine, right, this guy will rotate how many revolutions? So this guy will be here. In this case, it's going to be facing the other way around, and then when he comes back, he's going to be here. And then, for every revolution of the machine, this person will only rotate 1 time, right? And then likewise, this person will rotate only 1 time, right? So about this radius, let's say, right? And then this guy would also rotate 1 time, right? So it's going to be like that. Okay, so these people are sitting on the same rigid body, and then they would have the same angular velocity. Although this guy could have smaller velocity than this guy would have more velocity, more linear velocity as a point, but they would all have the same angular velocity, meaning they rotate the same number of rotations, right, for a given amount of time, for example. All right, and then this is what I mean by that. So if you have a rigid body, every line is going to be, for every 1 revolution of this rigid body, this line will rotate 1 time, this guy will rotate 1 time, and then etc. Okay, so this is very important. So a rigid body will have an angular velocity, and then meaning that every line on that rigid body is going to have the same angular velocity, not a point, right? A point cannot have an angular velocity. A point can only have a velocity vector. Okay. Okay, this for that, what I would like to do is let us start looking at rolling motion. So let's say I have a wheel, and in the case of rolling motion, you have two situations that could happen. Right, one way is that this wheel could be rolling and it's not slipping, meaning that there's no slipping between the wheel and the ground, and the other way is that there are slipping. So let's first evaluate the case where the wheel is not slipping. If the wheel is not slipping, basically this point here, let us actually call this point O. A point O basically is not going to be sliding on the ground, so essentially point O is going to be common to the wheel and to the ground. What do you guys think the velocity of point O is going to be if the wheel is rolling but it's not sliding?
دكتور
Yes.
رح تنزل السيشن على بلاك بورد.
Yes.
اوكي لانه مضطر سكر ما عليه.
Okay, yeah, that's fine.
اوكي.
Okay, so what is the velocity of point O?
If it's not slipping,
Yes.
It would be 0, right?
Exactly. If the wheel is rolling on the ground but it's not slipping, then the velocity of point O is going to be 0, right? So again, so the wheel is a rigid body, and essentially the wheel will also have some angular velocity omega. Okay, and let us actually put this frame ij. So the wheel is a rigid body, right? And because there is no slip in this case, then the velocity of point O is going to be, the vector point O is going to be equal to 0, right? And the reason is, for example, in your car, right, your tires don't wear very quickly is because the tire of your car is rolling but it's not slipping on the ground, right? So if it's not slipping, then there is no rubbing over here, and then there is no wearing. So if I'm trying to find the velocity of point G, which is the center of gravity of this wheel, how can I find the velocity at the point G?
We have the velocity at point O. We take it as our reference.
Exactly. So this is what we're going to do. So we're going to use our kinematics equation, and then I'm going to find velocity of G with respect to O, and I'm going to take point O as my reference plus omega, right? Omega cross RG with respect to O, right? What was the velocity of point O?
0.
0, exactly. How about omega? What is omega in this case? As a vector?
It's 2 pi r.
No, omega is angular velocity vector, right? 2 pi r is what? 2 pi r is perimeter of a circle, right? Omega
Yes.
is your angular velocity. So I'm trying to express this omega right here, right? I'm trying to express this omega in terms of my ij frame, right? What is omega in that case?
It's not in K. No, it's inward.
Yeah, so essentially you are going to use the right-hand rule, which we described earlier. So this is your omega, and then omega is going to be in a minus k direction, right? So omega is going to be equal to minus omega k, right? So this is a vector of omega. Okay, we said the angular velocity is a vector, so I can always express omega as minus omega k. Is that clear?
Yes.
All right. And this omega is like essentially, like we mentioned earlier, like theta prime, right? So if I have a line here, and if I have a line there, then omega is going to be the rate of change of the angle that this line is making with respect to any line, right? With respect to any fixed line. If that line is fixed, and you had a protractor basically, and then you were finding how much this angle between this line and then this fixed line is changing, it's going to be omega, right? As a value. In our case, omega is this vector, and let us try to find the velocity of g. So vg is going to be equal to omega, which is minus omega k cross rgo. What is rgo in this case? We said rgo is a vector that points from O to G, right? So this is my rgo, right? What is rgo in that frame? Assuming the radius of this disk is r, can someone tell me what is rgo?
دكتور ما عم بفهم هون، فيك ترجع تعيد بعد ما عملنا الأوميجا.
Yeah, so I'm trying to find the velocity at point G, right? So the velocity at G is equal to omega cross RGO, right?
Yes.
So I'm basically substituting omega with its vector, so it's minus omega k. How about RGO?
ال RGO هي من O ل G.
So RGO is actually equal to what? RJ.
RJ.
Okay. So right now what remains is you have to do the cross product of these two vectors, right? K and then J. And the easiest way to do a cross product is you have to do just simply write I, J, K, and then write it one more time. I, J, K. So K cross J, if I'm going to the right, then it's going to be positive. If I'm going from right to left, it's going to be negative. So K cross I is equal to J, J cross K is equal to I, but J cross I is equal to
Minus K.
minus K, exactly. So here, K cross J is equal to what?
minus I, but
It's
C
I.
minus I.
So it's going to be omega R times
I.
I, right? So there you go. So here is your velocity at point G, which makes sense, right? So we know if that wheel is rolling like this, then point G is going to have this velocity, which is equal to omega R in that direction, okay? Or theta prime times R. So there you go. So here is how you can calculate the velocity of this point. Okay.
دكتور نحن أول شيء when we wrote the kinematics equation كان في VG equals to V0 plus omega cross RGO بس كمان حطينا plus ال velocity.
Yes, the last term was the velocity of G with respect to O, right? In a smaller frame. And this last term, basically, if you use this term if point G itself is trying to move on this rigid body with some velocity. In this case,
Okay.
it's a rigid body, and then point G is a point of that rigid body that is not moving on it. If this guy was a bug, then yes, but here this guy is 0 because that point is not moving on this rigid body.
Okay.
Okay. Okay, so next, let us actually try to find the velocity of this point. Okay, how do I find the velocity of that point?
We take it with respect to
take
G.
the-
لا.
Exactly, so it doesn't matter. Actually, you should be able to get the same answer if you found it with respect to this point or that point, right? Let us begin by finding the velocity of point P relative to point G, now that we actually have the velocity of G, right? So the velocity of point P is going to be equal to what? Vg plus omega cross Rp with respect to G, right? Vg is just calculated, which was equal to omega R times I, right? Plus omega cross Rp with respect to G. So plus omega was equal to minus omega K cross, what is Rp with respect to G? It's going to be equal
minus
to
R, minus
No.
Ri.
Ri, not minus Ri, Ri, right? Why? Because from left to right, it is pointing in the I direction.
من G ل P مزبوط.
No, from G to P, exactly. So omega Ri, how about this cross product? What is K cross I? K cross I is equal to J, right? So I'm going to end up with minus omega Rj, right? So this is the velocity of point P, which sort of makes sense, right? So if this point is here, right, it's going to have downward component omega R, and then it's going to have a component like that as omega R, right? So this is your omega. This is your omega Ri, and then this guy is going to be your omega Rj. So your total velocity vector at this point is going to be in that direction, and it's going to be equal to what? Omega R, right? Square root of omega R squared plus omega R squared, which is going to be omega R square root of 2. Does it make sense? Or the magnitude of Vp essentially, right? It's going to be equal to square root of omega R squared plus omega R squared, right? Which is equal to omega R square root of 2. This is the total velocity vector.
أنا بس ما فهمت آخر شيء بس أخذنا ال directions لل R كل الوقت
What do you mean here?
بالإيكويشن تبع الكاينماتكس. أول
Okay.
واحدة ال VP equals to VG plus omega cross RPG.
Yes.
بس ترسم ال RPG كيف بيكون من وين لوين؟
Okay, so RPG is a vector that points from G to P always, right? So this is RPG. So P viewed from G. This is how you should think about it, right?
Okay.
P viewed. So this is a vector that is pointing from G to P, right? Or P as viewed from G, right? So this guy is R in the I direction, right? Is in the same direction as the I direction.
Okay.
Okay.
Thank you.
I'm going to redraw this one more time just to sort of really clarify it a little bit more. So this is your wheel, right? This is point O. We said it has 0 velocity. The center of the wheel is going to have what is the velocity of it? It's going to be omega times R. And we just calculate the velocity of point P with respect to G. And I said Vp was equal to Vg plus omega cross Rp with respect to G. And I ended up with omega Ri minus omega Rj, meaning that the velocity of this point is going to be how? It's going to have some component in the I velocity, and it's going to have this component in the J direction, right? Right? And ultimately, you can sum these two vectors into one vector, and then it's going to be pointing downward, right? The final velocity vector is going to be like that. Does it make sense?
Yes.
Okay, so let us actually try to find the velocity of point P with respect to point O, because also point O belongs to that same rigid body. And then let's see if we can actually get the same result. Okay, so velocity of P, how can I, okay, let me actually pick someone and then from our participants and then see, I'm gonna ask someone and then see if they know. And I'm gonna ask Julien Bifadil, can you tell us how can I find the velocity of point P from point O?
Yes. Vp equals Vo plus omega cross RPO.
RPO. Okay, very well.
Yeah.
Now, how can I continue from here? What is the velocity of point O?
It's 0.
Okay. What is omega?
Omega R. Omega.
So basically, what you're going to do right now, you're going to replace this vector, right? But so what is that vector going to be equal to? Minus omega k, right?
Omega k.
Minus omega
Yes.
k, right?
Okay.
Cross, what is RPO? Can you tell me what is RPO?
Yes, it's the vector pointing from O to P.
Okay.
So it's OP cosine theta I
What is that distance
plus
by the way?
OP
Do you know what?
sine.
Okay, مظبوط بس كوساين تاتا عم تحكي انه هيدي هي تاتا ما هيك but what is that distance from here to here?
Yes.
It's the radius.
It's
لا.
exactly ما هيك so RI ما هيك
مظبوط.
Okay. It's
Plus
RI
RJ.
plus RJ.
RI plus RJ exactly.
Okay.
Okay. What is K cross I? You want to look up here, right?
K
cross I is equal
I.
to J ما هيك?
Yes. Minus J. Okay. Yes.
Minus omega RJ K cross, right? And then K cross J
Yes.
is equal to minus I. Minus I have minus, so it's going to be
Minus
plus
I.
omega RI.
Plus omega R. Yes.
Okay, so this is basically the same result as this, right? So here we use a different point, and then what we used here, and then essentially we got the same result. Okay, which is equal to omega RI minus omega RJ. All right, guys, so no matter what you use, you would always get the same result, right? And from here, you can kind of tell that this is your final velocity vector here, right? And it is going to actually be perpendicular to RPO, right?
Doctor?
Because velocity of O is 0, right? So you only end up with omega cross RPO, and then this is the velocity of this. So essentially, guys, what I would like you guys to know for the exam is I'm going to be able to ask you the velocity of this point, this point, this point, any point on the rigid body, and then you should be able to find that velocity, right? So you could use this, for example, you could find the velocity of this point, and then you can use this point to find the velocity of this point, right? So this is the beauty of rigid body motion, is that there's, once you apply vector dynamics, you can get the velocities of any points on a rigid body very quickly. Yes, did someone have a question?
Yes, I wanted to ask if we should know that the velocity on the radius is always the same, but on the center, no.
The velocity of the radius?
No. All the points on the curvature. No.
No. So if a wheel is rolling, right, with no slip, right, then I know the velocity of the point that is in contact with the ground will be 0 velocity, right? So if I use that point as my reference, right, I'm going to end up simply with always omega cross RPO. So if I change this point to any other point, I will always end up with omega cross a vector from the point that I'm interested in versus this point. Can someone tell me how would the velocity vector look at this point here? Let's call that point P2. How do you think this velocity would actually look like over here?
Omega Ri plus omega Rj.
Okay, if I'm trying to find the velocity of this point, P2, basically I'm gonna have to reapply what I just did, right? So the velocity of, I'm gonna write here, so it's gonna be in the frame, VP2 is gonna be equal to VO, which is 0, right? Omega cross what? RP2 with respect to O, right? How does the cross product look like between omega and then this vector, which is RP2 with respect to O?
مش
Will be
minus
pointing
RI or
upward.
minus RJ? Minus
so-
RI plus RJ?
Okay, first of all, let us draw this vector. So that vector is going to look like that, right? Right, so this is your
Yes.
R P2 with respect to O. So I put a vector, no need for me to put a vector anymore. So omega, right? Omega is a vector coming downward across this guy. It's going to be a vector going upward, right? So we know this guy is going to be equal to this, right? So this is a velocity vector at this point, right? And it's going to be the magnitude of this vector is going to be equal to what? Omega times, right? Because omega across this guy, the angle between omega and this guy is 90 degrees. So here I will simply put the magnitude. And the length of RP2 with respect to O is going to be equal to R square root of 2, right? So it's going to be R square root of 2 times omega. Is that clear, guys? And the velocity of this point is going to be equal to the velocity at this point. How about the velocity at this point, P3?
And we do the same thing.
But
Okay.
2R omega.
2R omega, exactly, 2R omega. So the velocity at this point is actually equal to 2 omega R. And if you draw this, you're going to see that, this velocity basically grows linearly from point O. And later on, we're going to see that O is actually called the instantaneous center of rotation, right? And you would see that the velocities will always obey this rule, basically. It's going to be perpendicular to a vector from the center of rotation. But anyway, for now, what you should know is how you calculate them based on these equations that I just provided. What you have to do is express omega in terms of ijk, and then express the vector in terms of ijk, depending on what you are choosing for your reference point, right? If your reference point is a point that has 0 velocity, then you simply end up with omega cross RP2 with respect to O. Here we're finding the velocities of points on that rigid body. All right, so if you actually, so this is the profile of the velocity vector on the rolling wheel. Okay, guys, so is that clear? Any questions on that, or are we good?
Yes, doctor, I have a question.
Yes.
When we wanted to find the velocity of point P2,
Yes.
how did you directly know that the velocity is r square root of 2 omega لأنه قلنا r minus ri plus rj.
Exactly.
ولا
So yeah. So
Okay.
here basically you end up with just the, you know, when you are finding the magnitude of this VP2, right? It's going to be equal to this guy, right? So I know this guy is going to be omega RP2 over O times sine of the angle between them, right? And sine of the angle between them is going to be 90, so it's going to be basically 1. So omega times the length of this vector. What is the length of RP2? O is going to be square root
Okay.
of R squared plus R squared, right?
Yes.
Which is
So r square root of 2.
R squared of 2, exactly. And then multiplied by omega.
Okay.
Okay,
okay.
This is very good. Let us go ahead and then let us look at the accelerations of these points. So this is, again, so let's try to find the acceleration of any point on a rolling wheel. All right. So again, I'm going to start, you know, with that point, which is that is making contact with the ground, and then this is point G. Okay. What I do know is I know point O is limited to move. Point O cannot have any acceleration in the horizontal direction, and I know basically point G is going to be moving along this direction because I know VG is going to be along this I direction, right? So the velocity vector at point G will not change direction. Then the acceleration of point G has to be along the X direction or along the I direction. If I try to actually relate the acceleration of point G with the acceleration of point O, I'm going to end up with that. So AG is going to be equal to AO plus what? Can someone tell me what is the acceleration equation that relates G and then O? Well, I need to give you something more, right? I need to give you omega, and then I need to give you alpha, right? Can someone tell me how can I relate acceleration of point G with the acceleration of point O?
Alpha cross R JO.
G with respect to O, okay, plus what?
Omega cross Omega cross R كمان JO.
Okay, very good. So the last two terms, we're not going to use them because point G here is not moving or is not accelerating on that. And in the
بس شو
case of
هي
a rigid
الألفا؟
body where point G is not moving, I can always replace this guy by minus omega square RGO, right? This is
مظبوط.
equivalent to that. Okay, so I know point G,
سؤال الألفا what does it represent?
alpha is the angular acceleration of this rigid body.
Okay.
Okay, so I know, so right now I know AG basically has to be in the I direction. Point G cannot move up while the wheel is basically rolling on this horizontal surface. So AG is going to be equal to AGI. AO is basically constrained. AO cannot have, or point O cannot have an acceleration in the I direction. If anything, it may have an acceleration in the J direction. So it's going to be AOJ. How about alpha cross RGO? So alpha cross RGO is going to be equal to alpha R times I, right? And you can quickly tell if alpha is in that direction and the acceleration, tangential acceleration of point G with respect to O, it's going to be alpha RI. Okay, and the last one is minus omega squared RGO. Omega squared RG with respect to O is equal to RJ. Okay, you can, if you don't see this result quickly, you can simply do it, right? So alpha is equal to how much? Alpha is actually equal to minus alpha k, right? So if you replace alpha by minus alpha k and RGO is going to be equal to RJ, you can quickly see that this acceleration or this tangential acceleration will give you a tangential acceleration in that direction, or this angular acceleration will give you tangential acceleration in that direction. So this is what you have. And this equation is basically two equations, and it is not just one equation, it's two equations. And I can basically relate my I to I. So the I components on the left-hand side has to be equal to my I expressions on the right-hand side. So therefore, I know AG has to be equal to alpha times R, right? Or AG is equal to alpha RI, and AO, right? So this guy has to be equal to this guy, and then AO has to be equal to omega squared RJ. So AO has to be equal to omega squared R in the J direction. All right. So if you have a wheel and the wheel is rolling on the ground, then the acceleration of this point is equal to how much? Alpha r, and the acceleration of this point is equal to omega r, omega square r, and then this is only applicable if the wheel is rolling. This is point O, and then this is point G. If the wheel is rolling, basically, but it's not slipping.
Doctor, isn't alpha r the tangential acceleration and the other centrifugal equivalent?
No, so alpha r, right? Alpha r in this case has to be in that direction. Why? Because if you see here, this is your alpha, and this is my r. So alpha r basically, this alpha is going to give you the angular acceleration or tangential acceleration in that direction, right? Of this point, because this is my point of reference in that case. You can also get it simply by doing that, right? So this is all that I did, right? I'm trying to get the acceleration of point G with respect to the acceleration of point O. So I have to write AG is equal to AO plus alpha cross RGO plus this guy, right? And I know alpha and I know RGO, right? So all you have to do here is simply substitute the value of alpha and the value of RGO. The value of alpha was equal to minus alpha K. The value of RGO is equal to RJ. Minus alpha K cross RJ will be equal to alpha R in I direction, okay? And I'm doing this quickly because you would basically get that result very, if you also do it on your own. So is that clear, guys? Here, at least you are able to understand that the acceleration of point G always have to be equal to alpha R. The acceleration of the point on the wheel at the bottom will always be equal to omega square R. Is that clear, guys?
Yes.
Okay. Okay, now what I would like to do is let us try to actually find the acceleration of point P. How can I find the acceleration of point P?
You have to relate it to another point.
Okay. So let us find the acceleration of point P with respect to point G in this case. Okay, let me actually redraw this one more time and then so this is your wheel and this point has alpha r and this point has how much? Omega squared r. Okay, this is point O and then this is point G, and I'm trying to find the acceleration of point P. Okay, so let us use point G as our reference. If we use point G as our reference, then I know acceleration of point P is going to be equal to acceleration of G plus alpha cross RPG minus omega square RP with respect to G. So in the case of acceleration, essentially I can simply add them up. So the acceleration of point P is equal to the acceleration of G. So I'm going to take this vector and then I'm going to move it over here. This is a very legitimate move. Alpha cross RPG. So how do I do alpha cross RPG? So this is my alpha. Alpha cross RPG is going to be equal to this guy, right? Alpha R. So this guy is going to be equivalent to this. Why? Because you're doing alpha, right? Cross RPG is going to be equal to this vector, right? So this vector, so you take the cross product because you have the vector direction already. So this will be equal to simply alpha times R. R is the radius from, because distance from point G to point P is equal to R. So you end up with this. The last term is going to be equal to minus omega square RPG. What is RPG? RPG is simply R, right? So the last term is going to be equal to this guy here, omega square R, right? So the acceleration of point P is going to be equal to what? Alpha R minus omega square R in the I direction minus alpha R in the J direction. So, in a very basic approach, you can directly find the acceleration of any point on a rigid body simply by using these equations. Okay, now time is basically going to end.
Doctor, this last question.
Yeah, just one thing. So what I would like you guys to do is close and then log back in because this basically will expire in 30 minutes. So I'm going to close this session and then I'm going to open it again and you guys will come back in, okay? Okay. Okay.
Yes. For the last part, minus omega square RPG, you put on the drawing omega square R. حطيتها أنت من ال P لل G. Shouldn't it be in the other way?
No. So if you see here, minus omega square RPG, right? RPG is a vector that points from G to P. Okay? So
في
minus of
minus.
this vector is going to be pointing in the other direction,
Okay. Okay.
right? Which is basically the centrifugal acceleration. هذه هي omega square times R.
Okay.
دكتور
Yeah.
والالفا ار اللي بالجي دايركشن اجت من ورا الكروس برودكت.
Alpha R in the J direction. Yes, exactly, right? So alpha, right, is downward cross ما هيك RPG, right? So RPG is a
Yes.
vector. The arrow is basically my name, right? So RPG, so it's gonna end up with
Yes.
you know. And then one thing you can see is you can look at how alpha is going. So if alpha is going in that direction, this type of rotation will give you tangential acceleration in its direction, right? So you can't have as alpha in that direction.
Okay.
So if you reverse alpha, basically, you know this guy is going to be like that, right? This is why I quickly do it for you guys.
Upward. Okay. Okay.
Okay. So now let us try to find the acceleration of point P, but using point O as our reference point, right? So in that case, this is going to update, and I'm going to have a P is going to be equal to what? A O plus alpha cross RPO minus omega square RPO, right? Can one of you guys volunteer to help me to do this? And then let's also verify that this acceleration is actually the same as this acceleration, knowing that this guy was using point G as your reference, and now the new acceleration is using point O as our reference. Can someone help me with this?
يلا أنا بعمله.
Okay.
بس can you show us the value A0 شو كانت؟
What do you think is it's right here?
Omega square R.
اوميجا ايه اوكي هلا شفتها كانت فلو. اوميجا سكوير ار
J.
هلا مزبوط اوميجا سكوير ار جي بلس الالفا كروس ار بي او. Can we just go up to the drawing a little bit? Okay. الالفا كروس ار بي او يعني from O to P. يعني بنعمل
Well, let us go in baby steps. I really like baby steps because I won't make mistakes. So let us replace alpha by its value, right? What is alpha? What is the value of alpha?
alpha
Minus alpha K.
Minus alpha K, right? Minus alpha K. Cross RPO. What is RPO?
From O to P يعني omega square لا R I plus RJ.
Okay. How about the last one?
Minus omega square RPO.
What is
minus
RPO?
omega square RI.
So RI ما K plus RJ, right?
Yes.
Okay. Now let's continue here. Let's expand this further. I'm gonna end up with omega RJ, right? What am I gonna get here? So K cross I is gonna be equal to what? Again, I JK I JK, right? What is K cross I?
J.
J, right? So minus alpha RJ. Again, K cross J is equal to how much? Minus I, but I have a minus.
Minus I.
Plus alpha
Plus.
RI, right? K cross J is equal to minus I. Okay. All right. So here, the last one is going to minus omega square RI minus omega square RJ, right? So let's do this. What do I have in terms of I? So omega square RJ, and then this guy is going to cancel out.
Yes, we have alpha R and
alpha R minus omega R
omega square
J
R
plus minus, right? Minus alpha rj, right?
لا it's not J
one
الأول
is
it's
I.
I.
Yeah, I. Exactly. So this guy is I.
Yes.
So you can see basically we got the same result. Is that clear, guys?
Yes.
Yes.
Okay, so I, right? So I, you take an alpha r minus omega squared r. And so this is the beauty of rigid body motion, right? So no matter what you do, basically, you will always get to the same answer, right? So, and the reason, guys, why we are trying to find the acceleration of any point on a rigid body, right? Because let's say sometimes you ended up working for a company where you're designing some object that look very weird, and the center of gravity actually is here. That's called the G2, right? We would like to find the acceleration at the G2. Let's say, you know, the total vector is like this. Once I find the actual vector, the acceleration of the center of gravity, I can actually use this. I can say that this guy is going to be experiencing a force F is equal to m ag2, right? So once you find the acceleration of the center of gravity, you can quickly relate it to the force by multiplying the mass of that rigid body. Even though this object could look very weird, the fact that you are able to find the acceleration of its center of gravity or acceleration vector at its center of gravity, it means that you can find the force on that rigid body, okay? And you can decompose the force in the x direction and then the y direction. F is equal to ma this is basically three equations, right? Fx, Fy, and Fz, right, in the real world. Okay, guys, so this is what I wanted to cover for today. Okay, make sure you are very familiar with that. Make sure you are able to find the acceleration of any point in the rigid body. You understand rolling motion. You understand how to find the velocity of any point, right? So what I just did here, I could find the acceleration of this point maybe, and this point, any point, right? And this is the method that you should be very familiar with. Any questions, guys, on this?
Yes, doctor, I have a question.
Sure.
The last point you made on the circle is a distance مكانة R between O and the point. بتكون بدك تعطينا additional information يعني الانجل او شيء تنلاقي الديستانس.
Exactly, yes. I need to give you the geometry, right? So you can't just find the acceleration, yes, right? You have to know where this point is with respect to, if I gave you like you know this, and I tell you that this is like 0.1 meter, and then this angle is, you know, 45 degrees.
Okay.
Then basically you can relate it to this acceleration, right? Or even this acceleration, you know.
Yes.
All you have to do is just get the icon point of this vector. In this case, RG2 with respect to O. RG2 is what is RG2 with respect to O? You know, for the sake of conversation, what is RG2 with respect to O? So this vector will have an I component. Its I component is going to be equal to how much? Minus 0.1. ما هيك cosine 45.
Minus 0.1.
I ما هيك plus 0.1 sine 45 times J. ما هيك. This is with respect to O.
Yes.
If it's with respect to this point, then you have to add in the J direction. You have to add the radius.
Yes, 1R. Okay.
Okay. Any more questions, guys, on this? Or okay, in the meantime, guys, please start working on the homework assignments. Start to do some practice on your own, and I'll see you guys Friday with again lectures like that. Okay.
Okay, doctor.
Okay, guys. Thank you, guys. Bye bye.
Thank you.
Bye.